since we are making this video to make you understand all about the DSO, so let me demonstrate you how you have to again select for the crystal. If you have to check the crystal, what you have to do, you have to select your X1 into X10, again CH1 you have to press, and you have to select X10 as well here, and DC to AC you have to select. Now what you have to do, you have to check, let me open it. Instead of using on the crystal, I will recommend you to check it on the whether capacitor or on the resistor. So now you can see here that every time you will see, like this is also a crystal, this is also a crystal. So there would be always two terminal. If it is having a 4 legs, so only 2 legs would be working and 2 would be cross NC, not connected. So the both pin which is working, the one would be input from the PCH, and again the output will go into the PCH. Before going out, you will see that it is connected with a too high value of PF, and also there would be a 10 mega ohm resistor, the highest value you can see on the nearby the crystal. The 10 mega ohm resistor would be there. Now my motherboard is on, as you can see. Now what you have to do, you have to just press auto button as I have selected for the crystal checking. Now you can see here the 24 megahertz, as I was telling you that there could be the 24 or 25 megahertz, but you have to mind one thing, that both are not the equal, because instead of 24, if you are using 25, what would be the consequence? Your hard drive will not be detected, or maybe that you will not get the display data on the screen. So there could be various problems you have to confront. So avoid to use the different crystal, you have to match before you replace it. So now you are getting the input, proper input 24 megahertz input as well as output. Now this is the output, and as I have told you that in beginning video of DSO, that how you can determine which is the input and which is the output. So through the amplitude, you can say, by seeing this amplitude, this is the highest level, it is rising up as in compared to the input. As you can see here, the 100 millivolt is peak to peak voltage here, and maximum it is going to the 150 millivolt. Now in the output, now you can measure by yourself that it is going very much high. So my 25 crystal or 24, this is called the reference clock, which is required to generate PCH clock, that is called the embedded clock. Embedded clock will not be generated if the reference clock is not working. When this reference clock work, then after your embedded clock start to work, and then it send the communication data through the pin number 1, which name is chip select, and this is what you are getting the lower down the signal, which is falling edge is the getting communicated with the PCH. As of now, I have told you that this is the healthy condition of the CS, but if you are getting the only line, a single line of the 3.3 volt on the CRO, like here, if I show you, let me set it once again. Let me go back for the let me set it on the DC and test point. So one thing I would like to show you, that if you are getting the signal on this way, even after you just, like, since my motherboard is on, and suppose that your laptop is off as of now, and you are getting a voltage on the CS, and even after turning on the laptop, the same situation is like here, as you are getting that no getting down signal or not falling edge signal you are getting on the DSO. You can understand that your chip is not selected by the PCH, and data output pin will be at the high impedance, so there would not be data output. So here, as in the diagram, I would like to show you that this is the data output 2 number pin. So this will having a high impedance on the pin number 2. So high impedance is a tri-state. Basically, a tri-state is something that the register value or the value of this pin in the matter of impedance, it is going high. It will not allow the current to communicate or to pass from the BIOS chip to the PCH. So data output will not executed between the PCH and your BIOS IC. So the consequently you will not get the display in your motherboard. So this is what you have to remember, that at any cost while you are pressing on, it must be done. So after that, maybe that there would be a bunch of the rising edge and falling edge of the data you will get, but you have to measure only one thing, that this area you need to measure, that there must be a falling edge at the pin of CS while you are turning on the laptop. So this is what you have to care. So this is what I have shown you now. Now let's talk about the different pin, which is the clock pin. After CS pin, while CS pin is selected by giving you a falling edge of the data, then you have to jump on the pin number 6, which is clock. So what is the clock frequency? As I told you that if the clock is generated, the reference clock is generated, then it will wake up the embedded clock, and embedded clock will communicate with the LVDA section, with controller IO section, with BIOS SPI section. Now the clock section will be selected, and through the chip select it will come to know that what is the measurement of the BIOS frequency. So after knowing this thing, that there could be the 17 megahertz frequency for the reading and writing, there could be 33 megahertz frequency, there could be 48 megahertz frequency. At the time of CSME region cleaning, I have shown you that how you have to identify that which is the device. When you select the any BIOS program, there would be written that this allows reading and writing at the 48 megahertz frequency, there could be the 17 megahertz frequency. So each and every BIOS are different. So maybe you are using the BIOS instead of the customer original BIOS, may not be select because that mismatch of the frequency. So what you have to check here, so keeping your probe on the pin number 6, the same thing you have to apply, that you have to turn on your laptop and you have to see packets of data. So what is this? This is just a rising edge and falling edge. Now let me capture it once again. So capture is the one of the most important thing in the DSO, which helps you a lot to capture the data or signal in a very proper way. So now let me capture it. So let me put it on the 20. As if it is not giving the proper, like if the line goes here, then I will reduce the time. In this way you have to select the time. Like if I am on that time previous, I have told you that I was not getting the chip select. So then what I have done, I have reduced the time scale. So I have holding my probe on the pin number 6, that is the clock. Now you will see let me press on once again. Now something you have seen here. So let me do one thing. Let me set it 20 microsecond. Now let me turn it on once again. We are not getting any data on this DSO. So what I have to do, I have to select it like this way. Now as you can see, that there are some rising edge, falling edge, rising edge. You can adjust it like this way. I am adjusting it. Now you can see the rising edge, falling edge. What does clock do? That it gives the time to read the data and write the data. As I have told you in our theory class, that how it communicate with the PCH. When the chip is selected by PCH, what does happen? It sends some clock, then what time the data will be written and what time the data will be read. The BIOS execute only two things, reading and writing. So this clock gives the time for the reading as well as for the writing. So the timing is the very main important thing. While checking the BIOS signal, you may have to use the both channel CH1 and CS2. Why? Because you have to measure it at the rising edge of the clock. So now this is the rising edge and falling edge you are observing on the DSO. But actually this clock signal is not checked only. What you have to check it along with DO or DI. Data input or data output will be checked along with this signal with the help of CS2. So I will demonstrate you later. Let me define you all the pins, how does it function and what you have to care about while checking the pin of the BIOS. So now let's come back from the capture mode, and I would like to show you the two pin as I have described you in theory class, that WP. Once again let me describe it, that WP is the write protection mode, and what you have to care while checking the BIOS, then you have to check it that there must be 3.3 volt, 4 kb space is there, and which is responsible to stop the BIOS while writing from the PCH. When the writing process will not be executed with the PCH, then what will happen? No communication would be at the point of data input or data output. So consequently, you will not get display in the screen. So you have to be very careful while checking 3 number pin. There must be 3.3 volt. You can also see here the 3.3 SPI supply is coming through this resistor, 4 kilo ohm resistor, and you have to be very careful. Only you have to check 3 volt. Let me show you what do you get on this point. So pin number 3, 1, 2 and 3. So after CS, these things you have to check. The sequence I am telling you. Now you can see. So I forget to use reference ground. So that is why I may not be getting any frequency or any voltage. Now let me check it once again. So now as you know that this is the suspend logic, and you will get the voltage after turning on your motherboard. So now you can see no glitch, no ripple is there. A straight DC line must be appear on your DSO, and now you can see here 3.22 volt is available on the pin number 3, that is the write protection. So WP is the write protection, and it is the active low signal, and after being the active low signal, what will happen that it will stop entire BIOS for writing. So when does it write? So what is the advantage of this pin? That if this between the communication, if BIOS finds that something is going wrong or some mismatched data is coming into the BIOS, then what will happen? That the write protection pin will load on its value. It means its voltage. Lower down voltage will stop entire BIOS to communicate with the PCH. It will save your PCH to blow up, or you can say that to short circuit. So You have to only be careful, there must be 3 volt without glitch, without any ripple. So this is all about the WP pin. And one more thing you have to remember, that which is the hold pin. So now 7 number pin, let me show you. This is the hold pin, and there must be 3.3 volt like the WP pin. So this is also called the hold pin. Also it is known as the reset pin. So let me tell you one thing, that what is the hold pin. Hold pin is something which will hold the entire data, and while you check the CS is low, and at the same point of the time your hold pin is low, what will happen, your DO pin will go to the high impedance, and no communication will take place. This is the one thing, that if you are not getting the voltage on the 7 number pin, that is the hold pin. Now you can see it is hold. Sometime it will be written reset. The reset is used while same motherboard is having the 3 and 4 controller chip. Now in our laptop repairing, we do not hardly find in motherboard that we are having the more peripheral controllers in the motherboard. So single peripheral controllers we have, so that's why hold pin is there only. So hold pin's function is something like that. It if it is active low, then what will happen, it will stop communicating with the PCH. Why? At the time while your CS pin, the pin number 1 is lower down, as it falling edge of the CS, what will happen, your clock will be on the don't care condition, one thing. And if you are having low active signal at the pin of hold as well as on the WP pin, consequently you will not get display in your motherboard. So you have to be very careful. Many of us don't check these signals. We only care about the clocks, data and many more things. We stuck up there, and this pin could be responsible for the no display. So let me turn it on and let me demonstrate you what do we get on the pin number 7. Now I am holding my probe on the pin number 7, and let me turn it on, and you will see the 3.3 volt without glitch on your DSO. Since we are having the capture mode here, even if you are not checking it on the capture mode, you will get a line only, DC single line, you will straight line you will get on your DSO. So this is the indication that it is perfect, quite fine, there is no problem at all. Okay, so two thing on the 2 point of the BIOS, you have to you just don't need to get any clock signal or any data on the DSO. One is write protection pin and on the hold pin, and the hold pin could be named with the reset pin. Okay, so now let's move forward. What takes place after this? You have to check DI first. So DI is something which is data input. Somewhere you will know the name of the SI pin, serial input pin also is known. We have the 2 board for your demonstration. Here is the SI written. Now you can see on the schematic that PCH SPI SIR. So SI is the serial input, or DI could be the name. So data input is something which works, which is the data input which is coming from the PCH and entering into the BIOS IC. So DI is something which is the data input. It could be named with the SI, serial input, which is coming from the data is coming from the PCH. You have to remember one thing, PCH is the hub and master which is communicating to the host, or sorry, which is communicating with the slave, and slave is the your BIOS IC. Send the some data through this pin, and data will be written through this pin. One thing you have to remember, the data will be written by this pin. First, what does executed in the BIOS? It will not read. What does it do? It will write first. So in order to write the data in the BIOS with the help of descriptor section of the PCH. So descriptor section is something where all the information is written of the model. How will it communicate with the management engine? How will it communicate with the thermal section? Each and everything is described in the BIOS. As per the BIOS program, it communicates with the PCH and it executes the work. So this is what the DI pin. So you have to be very careful at the time of checking, but remember one thing, that this pin alone cannot be checked. You have to check it with the clock. At the rising edge of the clock, you have to check the DO pin. The DO will get high at the time while your clock is at the rising edge. And the contrarily, what you have to check, that at the falling edge of the clock, you should get the DO. DO should rise high. Let me describe it with the practical, that how do we recognize these types of data input and data output rising edge and falling edge with the help of clock signal. So now let's come and see.